Hey, how's it going? Hey,
Hey
Paul.
Matt,
Hey, Aaron. Paul, you're on mute.
you're on mute, Paul.
I am on mute. Yep. G'day, Aaron. G'day, Matt. Hello,
Hey, Paul.
everybody. Hello, Leonardo. We got some viewers from YouTube coming in today.
Very cool. Yeah, welcome everyone. For those that haven't watched Devs in the Shed before, we are in the process of getting Paul's shed set up at his new place. So no shed for Paul. And Aaron kind of rotates in and out, and I'm permanently set up working from my cabin. But the whole point of the show is, we work from our sheds quite a lot. We do a lot of tinkering with Raspberry Pis. We play with AWS all the time, all the new services. And we build things ourselves, and so we kind of want to share with the audience what we're up to in the current weeks, as well as bring in guest stars as well. We've got another person, Entree. Welcome in the chat.
Is that little flag from
From Brazil?
Brazil,
Yeah, the
yeah,
Brazilian flag.
Yep.
Yeah, really nice. So where is everybody else from? All of us are in Melbourne at the moment, which is quite a nice day today. Good, nice sunny day.
Oh,
I think-
it's
I
raining
think
on
we
this
need to-
side of Melbourne.
Oh,
It
is
is
it?
raining on the east, yeah. I think
it's
we need to
actually
start
really-
speaking French a little bit because I see that a lot of our viewers in the past have been from France. So bonjour. That's about the extent of my French.
Yeah, that's right. Actually, surprisingly, the YouTube videos, after we've kind of gone live, most of our audience is from France, which is pretty cool. Anyways, so this week, I don't think there's much to talk about in terms of what's new announcements, but
Actually, there's
I got-
one thing, Matt.
I got one as well.
Yeah, yep, go.
And maybe we just bring this up. So the AWS Code Build now supports ARM-based workloads in 4 additional regions. So I thought that was worth mentioning because here we go. Because we always tend to talk about anything that's happening with ARM. So yeah, I thought that was worth mentioning. That if you're using one of those regions in Europe, I mean, perfect for the French people in the audience today. So Paris, Seoul, Canada Central, and Europe, London now is available for Gravitron 2. For your code build, your build nodes. So now you can build your applications that are required for ARM processors if you're running on ARM. And Matt, you've always got something to say about ARM. Let's hear it.
Everybody that I know runs on ARM these days, so Mac M1s or Raspberry Pis, and I know that Windows now has ARM support as well. I don't know what else you want me to say here, but I'm a big fan of ARM because you get very powerful computers with a very low energy cost, and at the end of the day, that gives me substantially better battery life when it comes to my laptop, which I appreciate very much. But it also means that there's less of a power consumption footprint in AWS as well, right? And we're starting to measure carbon footprints and this and that in the AWS space, and Well Architected's got a new pillar devoted to that as well, which is pretty cool. But Aaron, what was the new announcement you were thinking about?
So you guys know that I'm a big fan of GIS and Amazon Location Service. For the Amazon Location Service, they announced 2 new Here map styles. So the Here Explore and Here Explore Truck are the 2 new styles that we've added. But the one that I like the most out of this, that excites me the most, is the Here Explore Truck. And this is because the map now has information that includes weight, height, hazmat restrictions, symbols that represent, where, segments of the area or the map that trucks can travel in and stuff like that. So this is a really good map feature for logistics, like people who actually do trucking and logistics and tracking. So, or not tracking, but route optimization. So knowing where a truck can go based on height and weight restrictions, as opposed to, I don't know if you know Melbourne very well, but there's a low-hanging tram bridge in South Melbourne that trucks often come and slam into because it has a height restriction and they don't realize actually how high they are. So to stop these types of situations happening in pre-planning.
Yeah, well, actually, speaking of that, Melbourne Reddit this morning, there was 2 trucks that got massacred by that bridge. So there's always at least 1 or 2 trucks every day. I don't know why we don't just change the bridge, but that's something that's unique to Melbourne.
They've put height restriction bars down the road so that if you're driving a truck, you'll smack into it and still people hit the bridge. So I don't know what's going on with these drivers.
Yep. Man. Anyways, today we're going to explore Fault Injection Simulator. So it's a chaos engineering platform that AWS has as a service. Fault Injection Simulators had like 2 releases quite recently. The first thing is that you can now use CloudWatch logs in S3. So you can kind of like start to keep track of what's happening in Fault Simulator in a more centralized space than using Fault Simulator itself. And then the other thing was like there was expanded use cases for ECS that came out, so you can cause like task level faults at the end of the day. But what I wanted to do was, I know some people will probably be new to chaos engineering overall. It's not something that many developers do day to day. Let me know if I'm wrong in the chat. Let me know if you've done chaos engineering experiments beforehand. But Aaron or Paul, like, how would you describe chaos engineering to someone that was new to it?
Well, I guess so. When one of the ways we tend to build and advise our customers to build on AWS is to build resilience into your application, right? One of Werner Vogel's favorite lines is like everything fails all of the time. And if you take that as like a preamble to determine like how you build and support your application, you start to think about like what happens when something goes wrong with my application. And I know we've talked about this a lot before when we talk about observability and watching and seeing what's happening with your stack, and making sure you've got alerts in place and all sort of things when things go down to react to that. But there's more to building highly available and highly resilient applications than just reacting to a fault that's coming down and saying, oh, okay, we're alerted, early. So, we'll jump on board and we'll try and bring that instance back up, or, search through logs and see what's going on. When we think about, building resilient applications, we want those applications to, 1, fail gracefully where they need to, if there's some major outage, or 2, have the ability to like stand themselves back up again and work through what is going in that area. Now, if you're building your application, you're saying like, what happens if something happens to my application? Now, things that happen to your application will almost always be something that you don't expect to happen. So there'll be weird things that'll happen, and it'll be like unpredictable. So if I take off the database and my application is connecting to that database, and my application is now got that wrapped up in like a try catch or something, we would expect to like not spew logs onto the screen, but we would expect to see a nice fallback page saying like, I don't know, our application is having some problem at this point in time. So like, okay, we'll say like, we'll turn the database off and we'll see what happens when that happens. Chaos engineering says, let's go ahead and automate all of our chaos that we're going to inject into our environment, and make sure that as we're running our environment, we're constantly injecting like chaos into that environment. So we're constantly doing things like turning off the database, rebooting the database, rebooting EC2 instances, for example, throttling the network and seeing what happens like if the network gets like really squeezed, increasing CPU load on a machine. And increasing CPU mode might have the effect of like scaling up or auto scaling, more instances. But and you might think, oh, okay, that's not even a problem. But like, how do you go ahead and like influence your application to like get itself into one of those twisted environments? So I think like that's like, it's a long-winded explanation, but it's basically injecting faults and problems or chaos into your running application and having it running all the time. And I would say that it became popular when I was working in the real estate domain, and we were following a lot of the practices that Netflix were putting out at that time. And I think it was like Netflix that really made like chaos engineering like popular when they introduced like Chaos Monkey and their
the Simian Army.
Simian Army, that's right. And they were kind of doing that. And there's like some really, really fantastic animations that show you like Netflix basically are doing this all the time. Like they're turning off instances, they're moving traffic around so that when there is a fault, it automatically moves to some other area. So you might get a small defect on your screen, or it might be a little bit slower to load the the little the slides or something that are coming up, or the cards, the movie cards. But your experience is not going to be completely destroyed. It's just going to like temper back for a little while.
Yeah, man, I love that explanation. Even though it was long, I think that was perfect. Like, the only thing that I would say on top of that is I have many discussions with site reliability engineers, and these are the guys that like engineer for known problems like disaster recovery and like understanding, when something fails, what went wrong, and going and fixing it and stuff. This is where chaos engineering comes into its own. And to your point around resilience and reliability and high availability, and how Netflix has proven themselves a superior product or system or distributed solution through actually developing their simian army, so Chaos Monkey, to make issues with their network or bring servers down or whatever, but to the customer having an uninterrupted experience, because you're watching a video, it's streaming from one node that goes down, but then it can pick up and provide from another node. This is the true essence of chaos engineering. Is to your point, like I'm just agreeing with, not adding anything to, is the resilience of the backend system in creating situations that you don't know how the system will react. So the more you do that, the more you test what you don't know, as opposed to disaster recovery, point in time recovery, like all these things that we can plan for, that we know it's going to take this long to restore. If we do a multi-region failover, we know it's going to take 3 seconds to swap from here to here. These are things that we know and things that are easy to predict. But chaos engineering is really about, if we, to put it in another metaphor, if we have a river and we add a dam here, what's the downstream effect? Is that going to, cut off water supply for this town? Or, if we then release the dam gates, is it going to go down the same creek path that's dried up, or is it going to form a new path? Is it going to flood, the whole region or whatnot? So it's looking at picking an upstream point and seeing what the downstream effect is. But in a distributed system, there are so many different points. And to Paul's point, it could be server-based, so it could be memory, it could be CPU, it could be network bandwidth of that individual server, it could be cluster-based. Now we're talking about accessing multiple nodes within a cluster. If we pull down a cluster, is it going to survive? Is it going to be able to heal and add another node to the cluster? What are the downstream effects of taking down an entire region? Do we have multi-region environment or multi-AZ environment where we've got redundant components that can take on the load for something else that goes down, going all the way down from server all the way up to solution? It's incredible what you will find when you don't know what you're looking for.
I think that's what that's the key point, right? It's incredible what you find when you don't know what you're looking for. Like if throughout my career I knew and it was building towards the what my expectation of the failures would be, like I'd have built a whole bunch of like resilience into my application, and I still would never have caught the actual failures, because they're always something different than you expect to happen. Like they're always something different. GetDev asked a really good question here. So I'll ask the question back to you, Matt and Aaron. A lot of people get anxious about performance and chaos testing in production. What's our thoughts?
My thoughts on this one specifically, because like the people like Netflix, Spotify, these guys are actually doing chaos engineering in production. It's about actually testing the resilience of your application. So yes, there's some maturity required. So you're not just going to go in and say, hey, I've got a 3-tier web application and I'm going to pull out the middle tier, because nothing's going to work and you're going to have a disrupted customer experience. It's actually planning your chaos engineering as a part of your solution. So it's not just, hey, we've got our solution, now we're going to start hitting it and making failures. The chaos engineering component, so the simian army for Netflix, is a part of their system. It's a part of the ecosystem that is their production environment. So they can run tests, ad hoc, untimed, so they don't plan for it to see how the system is affected. And they can also, you can do tests that you plan, scheduled tests, know that you've got less people interacting with the system. So run it during that low period, see how it's affected. And then, so you can do your labs or your tests to pick an action time to find out what the effect will be, to see what insights you can derive for when it would be the same thing at a high load time. I'm for doing testing in production, but only on a well-architected solution. So something that you've actually designed for chaos engineering, not something that you've designed and then come in and add chaos engineering to the end.
Yeah, I was going to say, like, there's a life cycle to this, I think, from my perspective. I would say if you're just starting out, you've got third-party dependencies through other partners. You've got other teams that are building microservices. You've got a complex code base that one or two people might have worked on, but you've expanded your development team to maybe a team of 8 or 10. Like, you're in the space where it's like you've got this app, but you don't know how things work around it. I think in those cases, it's about learning your app first, right? And learning about the dependencies of all these other third-party things that you have to rely on. And in those situations, I think to get comfortable, non-production is the best way to do chaos engineering. Because chaos engineering is a skill. Doing it in non-production is going to be mostly a replica of production, although I know that there's differences in scale and traffic that come into the equation. But doing these in non-production, you can see that you've got easy ways to restore back to a healthy state very quickly, and your team's built mechanisms to do that. Doing it in non-production also means that you get to learn like the basics of how things interact, but not at the scale of production, which is handy. And also you just get your team into a rhythm of being comfortable and not scared of breaking things. So I would say starting off, always do it in non-production. I know that's against the advice of all the books and everything else, but to me, that is actually the best way. Whereas if you are confident in your system, you're confident that you know how to restore quickly. You're confident that you've got like at least 10 different mechanisms in your apps as well to handle resilience, like back off and exponential retry systems. You've got like good monitoring in place, so you know what's happening in real time as well. The observability is fantastic. Like if you've got all those things in place, there's a list of 10 that I need to look up again. I've forgotten temporarily, but I did a whole Summit AWS presentation on it about 2 years ago. I think all those things like start to do it in production because your team should be skilled enough to handle what happens there.
Yeah.
The other thing is like you've got to be able, like some people are like, well, isn't chaos engineering just like, isn't that the same as unit testing? Like, isn't that the same as like doing some behavioral tests on my application? I get that question quite a lot, and I know it's not really the same. It's kind of like an evolution, right? So chaos engineering, you're kind of exploring how things can go wrong and how systems work. And when you're looking at unit testing, like you're really looking at just like the core pieces of the code of the app. You're not really looking at how the network flows, how the third-party apps interact with it.
Chaos engineering is applying a scientific principle to your testing. So it's now like if you understand scientific principle, it's I have a hypothesis. I need to create a action to test that hypothesis, and then I get a result from that action. I can then look at that result. I can then either change my theory, confirm it, or change my theory, and then create a new action and test my new hypothesis. So it's that continuous scientific theory that we add to systems testing.
Yeah, and usually to plan chaos, right? Like you write 2 or 3 of these hypotheses that you want to learn about your app. Like we think the app's going to act in this way. We're going to test these facilities. And you start small, so you don't just go around destroying EC2 instances, like pulling the pin like for an ACL block on something, taking down like instances of the database or whatever. Like you actually go a very defined way. Like when you're starting, like this is the test that I want to run, and this is my theory of how it will happen. And then you work on finding the tooling. So there's usually third-party tools that can help with a lot of chaos engineering. We're lucky now to have AWS Fault Injection Simulator to help with this on the AWS front as well. And so you go, okay, this tooling should do what we need it to do so we can run the experiment. And then you go ahead and run the experiment. You record the result as well. So that way you know in the future that if you do that action, this will occur, and it was to plan or it wasn't to plan. And if it wasn't to plan, you can put in mechanisms to kind of build some extra resiliency there. You can even expand those scenarios as well, like taking out the database, like one of the 5 instances read replicas that you've got is one thing, but then taking like all your read replicas down is another, right? So you can kind of expand the scope of the experiments as well, which is really like when you're starting, that's critical because you want to have a very small blast radius, even though you're doing it in non-production.
That I would call out in line with the point that you were making earlier. So the small blast radius, I think where I 100% agree with you is, and to the question that was originally asked, like doing it in production, you start in your non-production environments. That's your small blast radius, right? The difference between doing something in production and doing something in non-production is, this is what it took to my point to support what Matt was saying, is it's your maturity of chaos engineering, right? So you'd never say, as a new fledgling chaos engineer, let's do it all in production. You start with the smallest blast radius and you start increasing your blast radius until you get to production. So that's the maturity of your testing. The only thing that I would add to that is the importance of systems theory in terms of scale. Yeah, so understanding. Let me put it in an easy to understand metaphor. The difference between fox and rabbit, right? So an ecosystem that has both a fox and a rabbit. As you increase rabbits, the foxes are going to increase because the food supply increases. As you increase foxes, the rabbits are going to decrease because you're decreasing the food supply because you're increasing the predator, right? So if you now start testing this by increasing or decreasing foxes, what's going to happen to the rabbits? If you start increasing or decreasing rabbits, what's going to happen to the foxes? So this is ecosystems at scale, systems at scale. So there's a whole chapter on systems theory just around understanding scale, right? There are things that you can
Aaron,
test
on that example, though, I'm pretty sure we started with 0 foxes and 0 rabbits in Australia. And so that's like a real use case.
It depends what suburb you live in. There's plenty of foxes out in the east.
No, but now there is, right? Like, because
because there's plenty of food.
Well, that's a great example. Like, so that's it. You add a predator to a system that doesn't have predators, and slowly they take over. Cane toads in Queensland is a great example. But to that point, so
it's a side effect that you didn't expect to happen, right?
Exactly. So that's the point. At scale, you're going to see a different result than in a non-production environment where you've got a controlled scale. You know all of the inputs, so you know what's going to happen, or you can assume your theory is going to be a lot more accurate to the result of your action. Whereas in production at scale, what happens in non-production at a much higher scale may be unpredictable.
Yeah.
Now, we've actually talked about this a lot longer than I thought we would. Let's get into the example application, Paul. I'll take your screen up in a second.
Sure, so you can bring up my screen at the moment.
What are we going to do today, right?
So what we're going to do today is, like, I've built a Python application. So a very simple Python application. It connects. It's got a couple of EC2 instances, an auto-scaling group. It has a RDS instance, and you can seed that data into the RDS instance. What I'll do is I'll deploy that. And so I built that out into CDK, and we can talk through and look at the code while it's deploying in the background. So I'll just step us through like a little bit of the code in the application so we can see what's happening here. So I'm creating, like, the very first bit of this application is, it's using the standard VPC here. We're creating some RDS credentials. We create a couple of security groups that enables, like, these EC2 instances to be able to communicate to that RDS instance. And we can see here how we're adding those ingress rules. We can share this code later if people are interested in that. The code creates a RDS database, so it's a Postgres database. We can see here that when we're creating this database, we're not using like multi-AZ. So like, that might be something specific to call out, but you might be building your application, you haven't specifically specified multi-AZ for that, or you don't have a read replica of that database. You might be thinking straight away that's an environment or that you're thinking about that might have something to do with resilience. We then create a specific, like, we're going to create a number of EC2 instances, and I'm also going to use like the user data for those EC2 instances. So I've got a script, and I'll show that script in a minute, and that goes ahead and installs all the application and configures Flask to run on that application. We create a couple of roles, and we set up, for SSM so that we can connect through the console to this machine. We define an auto-scaling group, and this is something to take note of, like the minimum, maximum desired capacity. So I've set the minimum of 5 EC2 instances, maximum to 10. So if we were to load it up, it should scale up, and the desired capacity to 5 as well. So once this stack spins up, we should see 5 instances of this application running. We've gone ahead and added a tag to all of that, to anything that comes out of that auto-scaling group. So the project is stack EC2. We'll see why that's relevant once we go ahead and look into Fault Injection Simulator. We create an application load balancer and we forward that to the world. We don't worry about SSL. This is just a sample example application. So we're just exposing port 80 and we're letting HTTP traffic come to that environment. So that's the CDK to build this is, relatively simple with what it's happening here, but it means that like for this specific example, which Matt and I have used a number of times when we've been demonstrating Fault Injection Simulator and chaos engineering, is just a traditional or a typical 3-tier application that's running, within AWS, something that's fairly simple. It's got a bit of auto scaling. Because we've got load balancers there, we should see that we can, fail a percentage of those machines and the application still should keep running. If we do something to that database instance, because it's not running like a read replica or across multi-AZ, then, we expect this to be a weak point. I've specifically put some of these in so that we can maybe, see some failures happen rather than just, protect everything and build a highly, resilient application and just throw everything at it and it just keeps working. Like, whilst that would be, fun to see us like really brutalize this application, it's kind of fun to see the application itself fail.
Yeah, but this is realistic as well, right? Because someone might have written this CDK code for non-prod, right? And then they just didn't, when they flipped it to production, they forgot to change multi-AZ. So they could have been cost optimized in a sense in non-prod. But then they've just made the simple mistake of this CDK code is going to work exactly the same in production. And so you've been running in production for a fair while with single AZ and no one's noticed. Like, you think that's crazy, but I literally see that every week.
Yeah, these sort of things happen. Like, even the most advanced organizations, like, mistakes happen, and probably most of those mistakes happen from humans, which is why we continually to say, like, bring automation into your workflow. Like, if you're automating, well, you still might have made that mistake, but at least it's like trackable. You can see where you did it. It's repeatable in the same way. Whereas if I was setting up this stack manually every time, guaranteed you'd make some mistakes every single time. So your chaos, if you were trying to use chaos engineering with something that was like manually implemented, that's going to be incredibly difficult as well, because you're not quite sure what to do. You don't know whether you reproduce the environment. Is it slightly different? Is your pre-production, your staging, your QA environments, the same effectively as production? Automation is like a very important part of like, building resilient applications, making sure that it's consistent every time you're setting that up. I'll quickly show like the user data. So the user data, for those that are unaware, if you are spinning up EC2 instances, you can pass in specific scripts. So you can do it for Windows and you can do it for Linux. Specific set of instructions that will run as soon as that EC2 instance starts up. You can go ahead and you could package that and build like an AMI or an Amazon machine image that has your application on it, and you can package that all up. Or you can go ahead and like at boot time, go ahead and install the dependencies onto that machine and bring the code down and start it up. That really means that every time you start your application, it's like exactly the same as it was last time. And if you've got your code, like in this example, like as part of that machine booting, it clones that example repository and then goes ahead and sets up the application. That you're getting the latest version of that code that's coming out of a specific branch you point to. In this instance, would be master. I know that I'm going to get the environment spinning up exactly the same every single time. But the difference between doing it this way and maybe like having an AMI to do that is you may have like, in this specific example, we had a problem where the code had some specific versions of the Flask dependency being injected into the application, and it used to work, and now like it no longer works. So you've got to think about like what you're doing when you're starting up your applications, that are bringing in code, and you're installing dependencies like at boot time or at runtime to make sure that those dependencies are either fixed or frozen to a specific version, so that you're making sure you're getting them down, or package that up into an AMI and go ahead and deploy it that way. So for this example, we install Python onto that machine. Nginx is also installed. So this has been, we're hitting Nginx from the load balancer. Nginx is doing the proxy back onto the Python app. A few libraries around giving Python the ability to connect to Postgres. So a couple of libraries that are required there. We go ahead and cd into like var www. and there we go ahead and we create a virtual environment for Python. We've cloned that repository in there, and I'll take you through that in just a second. We install those requirements. We've defined a Flask service and set up all the permissions for those folders as well. Because we've defined that service and we've moved it into etc. systemd/system, we can then go ahead and start that Flask service, which is starting that application that we built in Flask. And we can set that up to run. So at this point in time, once the EC2 instance has started booting, Flask is running on that machine. So it's been installed, the files have been moved to the right location. That service is running as Flask, so you could configure that to restart itself or something. Then we go ahead and we set up and we move the correct Nginx config file so that Nginx will proxy any HTTP traffic directly to that Flask application. We start Nginx and we enable it as well in case that machine was to reboot for whatever reason. Also, as part of this, I install the SSM agent and configure the SSM agent for this application. Now, we'll just have a look at how that stack is going at the moment. So the stack has gone ahead and deployed. So it's deployed all those bits and pieces. And before we go ahead and look through the Flask code, I'll share this link with the audience so we can have a look at this. So if we go to, can you unshare my screen, Matt? So, because otherwise it'll do that loop back. So I'll paste in the endpoint here. And what I'll do is that should load up. So we should start seeing that come up. So you can share my screen again.
And you're back.
Okay, so I'll just move the two screens over so that I've got Fault Injection Simulator console on this side, and we've got our instances here. So in the console, we'll see that stack should exist. And if I was to reload this, I can see that there are 5 EC2 instances that are running. If I was just to kind of look at one of those, I should see the tags. We can see there's that project Fizz EC2 instance. So we know that stack is up and running. If I was to go to RDS, I should also be able to see that database is up and running there as well.
And the URL, could you click that on your end? For some reason, it's...
I've got it.
Because is it not working?
Hello world from Flask.
Yep, that should be it. So as long as that's working, then we know the application is up and running. So the application is obviously it's booted up, it's configured. At that point, what you're seeing there is just a route that's directly going to, and if we look at that, I'll show you. So I think it's this Python file. So the base route says, so here it is in the code. It's not doing anything. We know Flask is running. We know Nginx is running. We know those EC2 instances are running and that they're healthy. So that's really good for us. So we know our application's up and running. Now there's a seed task as part of this Flask application that seeds some sample data into a database. And what we'll do is we'll show, if we put /render at the end of that URL, so we'll see now that we've got our application. So is my screen still sharing, Matt?
Yeah, so you've got our mega stable app. I love the wording there because you're so sure of yourself, even though it sounded like there's a couple of problems potentially.
Well, I mean, I think if we went back
Netflix.
I think if we went back to the commits, I'm not sure whether that was me or that was Matt that did some of this.
If it's got emojis in it, I'm pretty sure that wouldn't be me.
Yeah. So I think Matt's being sarcastic there. I'm almost 100% sure that was Matt.
Yeah.
So if we were to go on this select data is literally doing a select from that Postgres database and just, I don't know, selecting the top something rather from the code. Let's have a look at what it's doing in the code here. Select data. So get vendors 500 and is that in one of our import files from, do we put it in utils?
I've just got 5, 1, 2, 3, yeah, 5. Number 1, AKM Semiconductor Inc., Asahi Glassco Limited, Dacon Industries, Delivery Fast Inc., and Dynacast International. So 5 different businesses.
Yep. So if we look at that method in the application, it's simply doing select vendor ID, vendor name from vendors, order by vendor name, limit, and then you can, we can pass in some sort of limit. So it must be, I'm just doing some random amount that come back and then just spit it out to the screen here. So that's just proving that, application is now connecting into, to that Postgres database. If we were to click run, within your browser, that is doing effectively just a poll, like every couple of seconds, every 2 seconds or 1 second, it's making that query back to that endpoint, and it's bringing some of that data. The output here is saying we've got a server-side try-catch within our code that we should see, we should prevent errors from the exception spewing onto the screen. But the front end may not necessarily have a try catch on it. So when the front end is making those polls, we would still see that an error would probably be thrown. You would still see the error that's being served from the back end being injected into the front end. So all it's doing is injecting the response from that into these little boxes. The bottom one is doing a try catch, but on the front end. So the top one is doing the try catch on the front end. On the bottom, it's not. So what might happen to the user in a scenario like this is, I think about this, if you're trying to list movies, I don't know, for argument's sake, list movies and get a list of movies, and you're clicking list movies, and the back end was throwing an error, the front end might just do nothing. Now, if it's doing nothing, you're like, what's going on here? You're clicking the button 100 times. Is that causing that stampeding herd problem to the back end? You don't really know. Whereas if you've got proper try catches and you're handling that on the front end, you can say, sorry, that service is not available at this point in time. Please try again in 15 seconds. Or, have a little timer and allows it to poll at the front end to set that up and going. So these are just some of the examples that you can think about when you're thinking about what happens when you're putting chaos into your application. The front end might be up here and running within your browser, but it might be confusing the user, providing a bad customer experience, rather than just logs or errors spewing onto the screen. The green, we can see here that's just, if a service is up, we can see the green being up there at the moment. So I'll go to the application here. Oh, great. It's logged me out of the console, so I'll just quickly log back in.
Yep.
Matt, can you just unshare my screen?
Already done.
Log that.
Yep.
Okay.
While you're logging in, I just realized that I need to get better at front-end development. Otherwise, people are going to stop thinking that I'm a dev. In comparison to your mega stable app, my micro front-end's graphics was very poor.
Limited color scheme and emojis, and then it looks professional even though you've got zero skill.
You don't like big red and green and blue boxes?
Yeah.
You can share my screen again, Matt.
Cool. GekDev asked, what's the stampeding herb problem that we just mentioned for people new to it?
So the stampeding herd problem is given that scenario that I just talked about then. So if you've got your front end that is, I don't know, let's say you click the button and it's supposed to download some, make a call to a third-party API and show that in a page. If you aren't handling an exception or an issue that's happening there, and the user doesn't know what's going on, or they're not saying oh, there's a problem, try again later, or you're backing off, and trying it again for them automatically later. As a user, you instinctively want to click many times. So that's a really good example of that happening. So I would click many times, and let's just say I'm just one of those people that's trying to add an item to my cart and it's not working. And if everybody else is having the same problem, all of a sudden that back-end service that is supposed to be taking the item and then adding to the cart or displaying that movie information, instead of getting, one request per second and failing and telling it, stop doing that so it can back off and can recover, because everybody's clicking and trying to press refresh hundreds of times, it's now getting way more traffic than it ever expected to get before. So not only is it failing, but it's now experiencing a traffic overload or, a service interaction overload. So
DDoS.
You've actually, you've actually DDoS, or you've caused more problems for your application than you originally began with.
I think the other thing is we can fix that easily by putting in retries, right? And half the stampeding herd problems that I hear about are actually because the retries keep trying every second. So you DDoS yourself with your application rules when you have a failure. Yep. So
and that's
it's
earlier
not just end
you said
users, right? Yeah.
That's exactly right. And because earlier you said exponential retry, and I meant to correct you at that point in time, because what you meant to say was exponential backoff. So
Yeah,
which means
exponential back off. That's right.
yeah, I knew that. I knew that's what you meant, but I thought that's what it means. And exponential back off says, like, if you have an automatic retry or you're retrying calling like that external API, like retry it maybe immediately. If that fails again, retry it after like 10 seconds. If that fails, retry after 20 seconds. If that fails, retries after a minute, and continually retry it at a longer period of time, so that you don't have that same problem where, obviously something's wrong. You've got to give it some time to recover. And hopefully if the end platform is resilient, it'll recover over time. But giving it a bit of a break and allowing it to recover is very important.
And even like, rather than having the app retry as well, this is also the advantage of having scheduled messaging queues. So if something's not that urgent, it doesn't need to be performed straight away. You can put it in the messaging queue to be tried again in an hour or something like that. And then that way you don't have like your app's state CPU cycles being burnt on doing this stuff as well.
That's the whole point of distributed systems and decoupling, being able to scale things out and process things in a timely manner when they're needed, as opposed to everything synchronously.
Yep, exactly.
But I want all the things right now.
Yeah.
Yeah.
So at this point, I've got my application that's ready to run. Obviously, like in this example, we're going to run directly in production. But in comes AWS Fault Injection Simulator. So this is like our tool that's come out. It's relatively new. There are constantly features that are coming out with that, but it enables you, and you can fully codify all of this experience with CloudFormation or CDK. We'll do it all from the console today. It allows us to create like experiments. So I'll take you through one of the experiments that we're going to create, and that should be the very easiest one that we'll do is we'll do stop Flask. So we'll try and stop our Flask application. Might not like the capital there. So obviously when we're executing experiments, these are going to do or perform like changes or something to the environment. Now that environment could be directly to like the underlying infrastructure, such as like networking or an RDS instance or EC2 instance. So we need to provide like a role for the fault injection simulator to be able to create that experiment. So if we click learn more, we can see that role and we can go ahead and apply it. I won't take you through that today, but you do need to have that role specified. So I've called it the fault injection role for that, obviously with the extra T there.
Yeah, I was going to say that's definitely one that you've named.
Yeah.
I'm dyslexic with words, whereas you're dyslexic sometimes with typing.
Yeah, that's right.
We balance.
And it's not sometimes, it's like, it's quite often. So now then we have this like concept of like actions and targets. And so an action is like, what are we going to do? And the targets is what are we going to do it to? And so like that's really the summary of what that means. So it's reasonably simple. Like the actions, we're going to do something to that environment. We're going to do it to these specific targets. We also have like the stop conditions. So if you were to go ahead and run this in production, you might say, I've got a CloudWatch alarm that says when errors reach over 40% or something, we're just going to stop the experiment and roll it all the way back. So there are like guardrails that exist for you to be performing your chaos engineering within production, or any environment at that point in time. But basically, like that is how you would go ahead and do that. So if you are running this in a production environment, you can set up specific guardrails to say, all right, just can that the experiment's going wrong. Like, let's just stop it and we'll roll it back. So even if you were, to stop that experiment halfway through, you can do that manually, but that might be very difficult to have eyes all over it. You can just automatically just say, just turn it off and just stop it back. So if you're running production, that's the way to set that back.
Can I say for that, based on the conversation we had earlier, like for that running in production thing, like if you were doing, so your blast radius, right, you wanted to test something with the least amount of users, then you could set up your condition to be when the concurrent user numbers come up, now we want to kill it because we only want to test it while we have a minimum amount of users in production, and then it doesn't affect all of our customer base.
Yeah, you totally could do that. And I would say like, you absolutely could do that, right? So most people would think that the stop condition would be stop when errors is just too much. You could just say, just stop testing now because it's,
Too many people.
It's 11 o'clock and we have our peak rush at 11 o'clock or something like that. So for our action, we're going to like kill some EC2 instances. So that's what we're going to do. So if we go into here, this session's expired too, I'll just reload the page. But if we look, we'll see like I've got 5 EC2 instances. We want to kill off a few of those. So here's where we can see the action types. These are the ones that come out of the box. So there's a bunch here that you can pick from. So we'll specifically look at the EC2 ones, but I'll sort of scroll from the bottom, and we can see that there's a lot of these specific actions that require like the SSM agent. So these run a specified SSM agent document on that specific machine. So this means that not only can you do things like terminate EC2 instance or reboot EC2 or something like that, or I don't know, do something to the network or reboot an EKS node or something. You can also run custom scripts that happen on that machine itself. So, and that might be something as simple as on that machine, you're going to run something that fills up the hard drive, and we want to see what happens if that hard drive gets completely full in production. So you can build SSM documents to have like any custom event or script be run on that instance, and you can integrate that within Fault Injection Simulator as well.
Can I call out? I just want to call out that example that you gave. That's actually a very common problem in large enterprise systems when developing like distributed systems. Many situations that I've seen in customer environments where actually the application developers and the infrastructure developers aren't so cohesive, where they're saying we need to log everything into the same place, which is, we would be doing logging into CloudWatch logs and everything, infrastructure and application. So then you end up getting all of the infrastructure stuff logged out to CloudWatch, but then the application logs are running into a local drive. And so then, when the application guys need to come and check what's gone wrong, they log onto the machine, they check their logs, they might clear them out and stuff. But there's a problem there that when the IO or when the disk fills up, that they're no longer able to access the disk. Everything comes to a grinding halt because there's no IO, there's no memory page swap out or anything. So the whole system comes to a crash. The infrastructure guys are scratching their head because they're like, well, I don't see any reason for this to be an issue. The application guys are like, okay, well, we know we need to clear out our logs. So it's a common problem more than people realize.
I actually had that problem a few weeks ago, right? And it was actually, the problem was we can't SSH into the instance that we want to open into, right? And it was disk exhaustion in the end. Yep. So that happens quite frequently.
Yep. Yeah, it does happen more frequently I mean, look, and like I said, you can build your own documents, and that's what like a real common one that I like talk to about my customers with. But there's a number of different documents here that you can run, such as CPU stress test, IO stress test on those machines, specifically just randomly killing processes on that machine, run it out of memory, throttle the network, reboot EC2 instances, fail over database clusters, just wait time. So like, you might want to wait at a particular part of your experiment for a particular period of time. Specific APIs, so you can take like specific APIs or the AWS APIs that exist, and you can like make those unavailable as well, and turn them off. And a good example of that is like make the API to Secrets Manager unavailable. What happens if your application is following best practices and storing its secrets in Secrets Manager? What happens if the API to Secrets Manager is unavailable for whatever reason? So there's a number of different specific pieces here, but what we're going to do today is we'll do a terminate instance one. So you can say like run this experiment for a period of time. You can say start this after, like there can be like specific actions or specify different actions. So you can set the order and you can move the order of these actions around. So I think so then you select the targets. Now, the way this works is slightly confusing. You specify the actions. You click save on those actions, and then we've got. I need to remove that. That went because I put the other piece on. So now I've got an action that says we want to kill EC2 instances. Now we want to specify the targets to terminate and kill what we're going to kill there. So and terminate. So we go ahead and we click edit. So we're looking now, and this is the target of this. So like we can see the resource types that we're going to specify. Now, if you were like on EKS, then that would be like an EKS node group. If it was like, something to do with RDS or an ECS cluster or EC2 spot instances, that will specifically filter down and narrow down the targets to that specific resource type. We're going to do it to EC2 instances. And you can specify your resource IDs and individually select those. So that's going to be really difficult. It's going to make this not repeatable because those specific instances are likely to be gone if I re-terminate that. So we're going to do that based on tags. And I think it was project. And if I go back to my code, what did I call it?
FIS.
Yeah. Where was that tag?
There you go.
Here it is. Visstack EC2. So I'm going to specifically target EC2 instances that are targeted with that. And I will, the selection mode for that, I'll choose a percentage. For that percentage, I'll say, let's kill 40% of those EC2 instances and see what happens. I won't worry about a stopping condition. I'm not really concerned because this is just a specific example that we know it's pre-baked. And for our logging here, we can go ahead and we can send those to CloudWatch logs, and we can send that to an Amazon S3 bucket as well, so we can look at what's happening in the back end and what is going through. So we can log all of those, get all the insights out of those logs later. Now we'll go ahead and we'll create that experiment template. There's plenty of warnings around this, and that's to make sure that you know what you're doing. Basically, if there's no stop condition, this can be you would have to manually stop that experiment happening at that point in time. So if you start an experiment without a stop condition, a little bit dangerous unless you manually stop it. It's just going to keep going, and it could really damage your application. So if we were to sort of look and we see, I've got a number of instances running there. If I go back to my application, I can see that it's still working, and I can still see the green here. Now what I'll do is now that I've built this experiment template, I'm going to go ahead and run that. So we'll click start. I haven't configured any logging on this, as we saw. I didn't select that. You can add your tags to that experiment so you can track that later and see where that was run. But we're going to go ahead and we're going to start that experiment. So we need to be confirm that we do it. Start the experiment. Plenty of warnings there, and we see that experiment has now been initialized. Now what we should see is Fault Injection Simulator will assume that specific role. That role will have permissions to be able to terminate EC2 instances. And what we should see is, there we go. So one of those instances must have been terminated. Now, if we go into the console, we'll see, and I'll reload here. See there, I've got 2 instances of shutting down. So the Fault Injection Simulator has terminated 2 of those specific instances. My application did have a red go through. Now, for anybody that's building an application that is on EC2 instances or sit behind a load balancer, like Elastic Load Balancer Network or Application Load Balancer, knows that you can still get a bad request being sent to a load balancer, even if you have many machines that are up and running, within that target pool. That can happen because the load balancer hasn't detected that machine has gone out of service at that point in time. So you can still get that. But the very next time you're going to request that, you're going to get a different machine, or hopefully by then that application, that EC2 instance has been pulled out of that target group and has been deallocated from that application load balancer. Hopefully, and by then another one has begun to spin back up, and you'll be directed to a good instance. In this example, we saw that it was only one of those 1 second outages that was detected. So the user might have a poor experience at that point in time, and they're like, the website went down, they hit refresh, and the website's back up again. To check whether our application has come back up again, we would if you configure that manually, you might have configured 5 instances running. You might be really content with having 5 instances running. That handles your traffic really, really well. But 2 of those instances have been broken. What has happened to my application? Is it now going to be stressed really hard because it's only running on 3? Or if you've configured that correctly and auto-scaled has been put in place, we should see that by this time, if I reload the page, we should see that there should be 2 more instances running. Maybe 2 of those are still in the starting mode. So yeah, we can see that the 4th one is initializing. We should see in another minute or so, the 5th one should come up as well. We should see that our application is auto-scaling properly. New instances of the application are being spun up as the auto-scaling group has detected that more of those have been terminated, because we set in our CDK minimum instances as 5. What was the other configuration that we put there? Recommended instance running. I forgot what that terminology is called. Desired capacity is set to 5 as well. So we should see that there's 4 here now. If we refresh again, a minute or so, the auto scaling will take over, and we'll see that another instance will spin up at that point in time, and we'll see that, we're seeing our application now being able to handle those faults, that the application, if we do terminate an EC2 instance, we can see that it starts itself back up again. Very little outage for the customer. Our application is still up and running, as we can see here. We're still connected to the database and we're running that through. And there we go. So the fifth one has now brought itself back up as well. We've got a couple of minutes, so maybe I can do one more experiment. Are there any questions or any comments that are coming up?
We've got somebody that is walking the dog. They need to go for a dog walk soon. That was fun on the chat. But I liked Andre's comment. My kid in application availability set the time to sleep on. I think Aaron can relate to that. He's his kid kept him up yesterday.
I don't know. I don't understand. What's sleep?
Yeah.
But also, like, I think chaos engineering is probably the perfect way to test that availability within business hours and build ways to make it more resilient for sleep time.
I do want to say, like, to the point where we were talking about the explosion radius, I think, like, for everything that you've just done here, Paul, this is awesome at showing like a controlled experiment. So this action is, we know that the result is going to be blow away some EC2 instances. We know that the auto scaling group is going to start coming up. So we have an idea, like our theory and our result for that action are in alignment. But now if we start introducing, still running that same one, but now we introduce like kill the flask on some services, but then kill other entire EC2 instances, now introducing multiple actions, that it's that whole ecosystem discussion again. Now we've got EC2 going out, we've got application level going out, we may have network throttling happening. As you start to increase, like in isolation, one is fine. We understand how that's going to happen. Another one in isolation, that's fine. We know how that's going to happen. But when you start adding multiple together, this is the chaos. This is the chaos in chaos engineering. And the explosion radius gets bigger by understanding lots more pinch points in your system as they are wiped out or throttled or whatever, how much of an effect on your system, your entire, your application running, and we can see the little red node when it goes down. But the actual output here, the server-side try-catch, or the data that it's outputting is pretty constant. So we can see that the customer experience is constant, but we're now starting to add additional chaos to the system to see how far we can push the limits of, customer consistency.
Yeah, to me, like, one of the things I just love about this is, like, how long does it take for scaling to happen within my instances? And how long am I going to be in this degraded state, right? Like, what does it look like for the end users? One thing at the very start, we saw that 5 seconds. But then it's also like, how long does it take for, the scaling of my instances to recover? Like, for the amount of availability that I need to cover my load to be there for everyone. I was going to say the database one's really fun, Paul. I don't know if we have time. Yeah.
We'll have time. So I'll do resource tags. I'll add the tag.
Any questions from the audience as we go here as well, right?
I'll just add to what you were saying there, Matt. Like that for a distributed systems engineer, what you just said then, that's the important part of chaos engineering. It's not the actual doing the chaos engineering. It's the result and finding out, well, we know now that it takes so many seconds to spin up another instance. Do we start making our system more resilient or highly available by now running 2 target groups that have, a redundant level of services that can run in parallel, and so then if these start getting hit, do we fail over to the other target group? Are we load balancing between them equally? Or, this is now the discussion between failover versus highly resilient, highly available.
Yeah, exactly. Yeah, it's those little things. It's just like now, like defining like SLOs, SLAs, like all these recovery RPO, RTO, all these recovery type stats, right? Like all of this comes into it. Understanding more about our go Paul.
Yeah, just quickly. So you can see now I've got like a number of actions. Those actions can happen over the top of each other. So I didn't set them to start one after the other. I just set them to happen at the same time. And the target is, again, the EC2 instances and the database. So I'll save and I'll run that experiment. So you guys can keep talking while it's happening.
I'm done. I don't have anything more to say.
Yeah, you've just killed the moment, Paul, but that's okay.
I only did that because I was noticing that we're hitting our time.
Yeah, no, that's okay. While this is going, so while you're running this experiment, next week's going to be really fun for everyone that's watching. It's same time every week. 12 p.m. AEDT time zone in Australia. So we start exactly an hour ago every Wednesday, every today because it's Tuesday for some people. In terms of next week though, we have Derek Bingham, one of the developer evangelists from AWS, coming on. We're going to have a fireside-esque chat, which the fire is definitely not going to be in my cabin. But we're going to talk about, programming trends this year. Like we talked a little bit about micro front ends last week. We're probably going to talk a little bit more about that. I know Derek's really keen on Rust. There's been some changes to Go that, he's quite excited about. GraphQL just keeps expanding over and over again. So probably going to talk a little bit about AppSync and, where we see, those types of trends go as well. So next week's going to be a really good chat. I just confirmed with Derek as well. And he's excited to come on the show. So make sure you chime in next week, same time.
Yep. Yeah, I'm looking forward to that one as well. If we just saw like that experiment is running, so it's probably nearly run by now all the way through. Yep, it has. But you can see that RDS instance was rebooted. I wasn't quick enough moving between the tabs to see whether the application went down.
I was watching it.
RDS
we did have
does go
two.
You had a blip?
Yeah, we had 2 red boxes, and then it was green again.
Yeah, rebooting RDS happens like very, very fast. So you sort of have to be watching it, especially this database, a tiny little database, 100K of data in there or something. But yeah, like you can see now that we're both rebooting EC2 instances and the database at the same time, and our application is still kind of running. We have a little bit of downtime. If it was a big database that took a long time to reboot, then having read replicas would probably be something that you'd want to consider at that point in time. But that just shows you like how quick and easy it is to go ahead and start setting up those experiments. You can codify all of this and put this as part of your pipeline if you wanted to go ahead and do that. You can specify like your tags to do it. You can specifically target those instances. So you might be still having your application be like fully like scaling up and down and tagged really well, but the database might be some legacy thing. You can specifically target that resource ID if you need to. And there's a lot of options around Fault Injection Simulator. Because it is a new service, there are constantly new faults that are coming out and new availability for us. And as well as like, there's a lot of like SSM documents that are available, such as like killing processes, filling up the hard drive, running it out of memory and so forth as well. So yeah, I hope that's been a fun session. Did you want to share my screen, Matt?
Yeah, I was going to go to Andre's question as well. Do you guys already use Resilience Hub integrated with FIS? So Fault Injection Simulator. So Resiliency Hub and Well Architected I kind of view as kind of very similar to each other, right? Well Architected is going to help build the resilience of your app by asking your team the right questions as to what's happening in the workload space and what are the risks. That's a really simplistic view of Well Architected, and the Resilience Hub is really good for tracking and calling out those risks as well, right? And it integrates into Fault Injection Simulator, Systems Manager, if I remember correctly, CloudFormation, CloudWatch, and all those types of tools. So yes, definitely use it. But today we just we knew we'd be short on time, just showing off Fault Injection Simulator and getting passionate about chaos engineering in particular.
I'll just add, so Resilience Hub helps you design for resilience. However, you don't know what you don't know. And that's exactly why we do chaos engineering, is to find out what we don't know.
Yep. We'll probably publish that code so that people can go ahead and run those experiments themselves. So like you can go ahead and spin up that stack and go ahead and practice some experiments on that and play with it and see what else you can do to your environment. Just make sure that when you, we'll put it in the README, make sure you turn that off, because I think the EC2 instances were kind of big. I made them big so that it would start up faster.
That was awesome, Paul.
Done. Well, we'll catch everyone same time next week. Please join us. Derek Bingham's going to be on here. It's going to be a great conversation around developer trends this year. So I'm really excited personally about next week, and I hope I see everyone there. Thanks for watching.
Take care. Bye.
Bye.